Hi, it is JIT UA Courses, and welcome to lesson number 11 of the .NET Developer series, in which we will cover the most relevant topics to becoming a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will learn about interfaces and abstract classes in C#, and also extension methods. If this sounds interesting to you, don't hesitate and hit the like button. Abstract classes and methods. In C#, abstract is a keyword and is used to denote classes and class members that must be implemented or overridden in a derived class. You can use the abstract modifier with classes, methods, properties, events, and indexers. Members that we define as abstract and that are included in an abstract class must be implemented by classes derived from the abstract class. In other words, an abstract class is like a template class. We cannot create an object of an abstract class, because it is not a full-fledged class, but just a template that needs to be finished. The classes that are inherited from the abstract and implement its empty abstract members can be full-fledged objects. Abstract class. An abstract class is a class that is declared with the abstract modifier. If we define a class with an abstract modifier, then that class is only meant to be used as a base class for other classes. An abstract class cannot create instances, and it can contain both abstract and non-abstract members. A class that is derived from an abstract class must implement all inherited abstract members. In C#, you can define an abstract class using the abstract keyword. Below is an example of defining an abstract class using the abstract keyword. If you look closely at the code snippet above, we have defined an abstract class, info, using the abstract keyword with the getDetails method signature. If we define a method with an abstract modifier, then the implementation of this method must be done in the derived class. Below is an example of implementing a class by deriving from an abstract class. Here we have inherited the abstract class, info, in the user class and implemented the defined abstract method in the user class using the override keyword. In C#, abstract methods are internally treated as virtual, so a derived class must override these methods. In C#, we should not use the sealed keyword with an abstract class because the sealed keyword will make the class non-inheritable, but the abstract modifier requires the class to be inherited. Abstract class features. Following are the important features of abstract class in C# programming language. Abstract classes cannot be instantiated. Abstract classes can contain both abstract and not abstract members. We should not use the sealed keyword with an abstract class because the sealed keyword will make the class non-inheritable, but the abstract modifier requires the class to be inherited. A class that is derived from an abstract class must include all implementations of the inherited abstract members. Abstract method. An abstract method is a method that is declared with the abstract modifier. If we define a method using the abstract modifier, then this method does not contain any implementation, and the method declaration ends with a semicolon. Below is an example of defining an abstract method. Abstract methods are only allowed to be declared in abstract classes, and a class derived from an abstract class must provide an implementation of the defined abstract methods. Abstract methods are internally treated as virtual methods. So these methods must be overridden in the derived class, and we must not use static or virtual modifiers when declaring abstract methods. Abstract method features. The following are the important features of abstract methods. Abstract methods can only be declared within abstract classes. It contains only an abstract method declaration without implementation. Only derived classes will provide actual implementations for abstract methods. Abstract methods are internally treated as virtual, so they must be overridden in the derived class. We should not use static or virtual modifiers when declaring an abstract method. Abstract properties will behave the same as abstract methods, but the only difference is in the syntax of declaration and call. Interfaces. An interface is the same as a class. Still, The only difference is that a class can contain both declarations and implementations of methods, properties, and events. Still, an interface will only contain declarations of methods, properties, and events that a class or struct can implement. Just to clarify, since C# version 8.0 interfaces can have a default implementation for their methods, but that feature is not in the scope of this lesson. An interface is more like a contract. A class or structure that implements an interface must provide implementations for all members specified in the interface definition. A contract is like a declaration of an action that this class can do. For example, we have a service that sends a message and has an interface type. The main thing for it is that it knows how to send a message. And the class that implements the sending of the message itself can be the class that sends SMS, and the class that sends messages to some messenger, and the class that sends messages to email. The implementation can be different, but it is important for us that the interface, how we will use it, is preserved. Generally, C# does not support multiple inheritance of classes, but this can be achieved by using an interface. Also, a structure cannot be inherited from another structure or class, but it can be inherited through interfaces. We can define an interface using the interface keyword. Below is an example of defining an interface using the interface keyword. If you look closely at the code snippet above, we have defined an interface, IUser, using the interface keyword with the signature of the insertDetails method. Any class or structure can now implement the IUser interface by defining the insertDetails method. To implement an interface in a class or structure, the syntax will be similar to what we have used for classes. Below is an example of an interface implementation in a class. Here we have inherited the interface, IUser, in the class, user, and implemented the defined method of the interface in the class. An interface object cannot be instantiated directly, but it can be instantiated by a class or structure that implements the interface. Below is an example of creating an instance of an interface in the C# programming language. In C#, a class can inherit from only one class, but we can implement multiple interfaces in a class or structure using interfaces. By default, interface members are public, and we are not allowed to include any other access modifiers. An interface can contain methods, properties, events, and indexers, but it cannot contain constants, fields, operators, instance constructors, finalizers, or types. In addition to the implicit implementation of interfaces, there is also an explicit implementation of the interface. In an explicit implementation, the name of the method or property is specified along with the name of the interface. In what situation might you really need an explicit implementation of an interface? For example, when a class implements multiple interfaces, but they have the same method with the same return result and the same set of parameters. The person class defines a single study method, creating a single common implementation of both implemented interfaces. Regardless of whether we consider the person object as an object of type iSchool or iUniversity, the result of the method will be the same. To delimit implemented interfaces, you must explicitly apply the interface. Below are the important properties of the interface in the C# programming language. An interface is like an abstract class and can only contain declarations of members such as methods, properties, indexers, and events. By default, interface members are public, and we are not allowed to include any other access modifiers. An interface object cannot be instantiated directly, but it can be instantiated by a class or structure that implements the interface. A class or structure that implements an interface must provide an implementation for all members specified in the interface definition. A class or structure can implement multiple interfaces. Difference between abstract class and interface. Below are the differences between an abstract class and an interface. Abstract classes cannot be instantiated. An interface cannot be instantiated directly, but it can be instantiated by a class or structure that implements the interface. An abstract class can contain both declarations and implementations of methods, properties, etc. An interface can only contain declarations of methods, properties, indexers, and events. Members of an abstract class can contain different access modifiers. By default, all interface members are public, and we are not allowed to include any other access modifiers. A class can inherit from only one abstract class. A class can inherit multiple interfaces. A class that is derived from an abstract class must implement all inherited abstract methods and accessors. A class or structure that implements an interface must provide an implementation for all members specified in the interface definition. Extension methods. Extension methods are useful for extending the behavior of existing types by adding new methods without modifying, inheriting, or recompiling the source types, such as a class, structure, or interface. In C#, we can implement custom extension methods for any .NET type, such as a custom class, a .NET Framework class, or third-party classes. To create an extension method, we need to define a static class and implement the extension method as a static method with the required parameters. The first parameter of the method will indicate the type on which the extension method will operate and must be preceded by this modifier. Below is an example implementation of an extension method for the system.string class. If you observe the example above, we extend the behavior of the string type by creating an isValidEmail extension method. Extension methods are the same as static methods, but the only difference is that the first type parameter in an extension method must be preceded by this modifier. We need to include the extension's namespace in our application wherever we want to access the isValidEmail extension method as shown below. After adding the namespace, we can access the extension method as an instance method of the extension type as shown below. Extension methods must be declared as static methods of static classes, but are used as object methods of the class. When creating an extension method for a given type, we must first ensure that a similar method with the same signature does not exist for the specified type, otherwise, the extension method will never be called. This is how we can extend the behavior of existing types by adding new methods without changing the original types. Following are the important points that we should remember about extension methods. Extension methods are useful for extending the behavior of existing types without modifying, inheriting, or recompiling the source types. We can create an extension method for any .NET type, such as a custom class, a .NET Framework class, or third-party classes. Extension methods will be defined as static methods of a static class with the necessary parameters. The first parameter of an extension method must specify the type on which the method will operate and must be preceded by this modifier. Extension methods can be used anywhere in our application by including the namespace of our extension method. Extension methods are used in the same way as instance methods of an extended type. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell so as not to miss the following videos in the series. Feel free to leave a comment and like this video. You are also welcome to leave any questions in the comments section. I will be happy to answer them. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.